Hey there everyone, welcome back to another video, and today I've brought you something new. We are going to start a new series which I call the 06CHEM20, where I'm going to be covering all the chapters before the IGCSE exams. So today, because we know that the syllabus is our biggest help in studying any science subject, at least for me, I'm going to be starting with the first chapter, which is states of matter, and we'll be going over it. So without any further ado, let's get started. Okay, so the first chapter, which is states of matter, 1.1, solids, liquids, and gases. Now, the first point asks us to distinguish the properties of solids, liquids, and gases. Now, this is a pretty basic thing that you should know by heart, but I'll still go over it. Let's begin with solids. Solids have a regular arrangement, they vibrate about a fixed point, and they have a lattice structure. Now, a lattice structure is basically the regular arrangement. They have fixed volume, high density, and particles are very close to each other. So now the way you can visualize solid particles is something like this. Okay, so imagine these are the solid particles. You can see that there's a regular arrangement between them, and now they will vibrate at a fixed point at where they are. Now this structure that they have is called a lattice structure, fixed volume, density, and the particles are very close to each other, right? That is for solids. Then when we look at liquids, this is what liquids will look like. Very similar to solids, but not exactly the same. Now you see over here, you see that there's some space over here, right? This space that you see. Now this space allows particles to slide past each other. They are less dense than solids. They also have a fixed volume, because when you have a container like this and you pour water, it will take the shape of the container. And now we know that over here there's a fixed volume. That's why we say liquids have a fixed volume and take the shape of the container. So that's for liquids. Moving on to gases. Gases can be represented something like this. I have a molecule, I have another one, and now this shows that there's no fixed volume, right? It takes the volume of the container that it is. Or let's say I have a cube, okay? Let's say this was a cube, and the volume of the cube was 20 cm cube. So that will be the volume of the gas as well. It takes the shape of the container. As you can see, it has lower density. There are fewer particles that are moving very fast and randomly in all directions, and they collide with the side of their container. Now these are the properties that you needed to know, and this is basically the same as 1 and 2. Then describe changes of state in terms of melting, boiling, evaporation, freezing, and condensing. Okay, so basically this is how I remember it. I put solid in the middle, I have liquid on top, and I have gas over here. When there's a change of state from solid to liquid, there's melting, and liquid to solid is freezing. Solid to gas is sublimation, or sublimation, and gas to solid is desublimation. I think you can also call it deposition, but just check and then confirm if it's called that. Now from a liquid to a gas, it's boiling or evaporation. Now the difference that you need to know between evaporation and boiling is that evaporation happens over a range of temperatures, and it happens at the surface. Okay, in boiling it happens at a fixed temperature and happens throughout the liquid, right? Now these are two differences that you need to know, because I've seen questions come up on that. So we are done with this. Describe the effect of temperature and pressure on the volume of gases. Now it's simple. When the temperature increases, the kinetic energy of particles increases, causing them to collide with the container more often, causing the volume to increase, which means they're directly proportional. When volume decreases, that is when pressure increases, because you have so you have a container like this with your particles like this, big volume, and you have a smaller container with your particles like this. There will be higher pressure over here. That means that pressure and volume are inversely proportional, whereas temperature and volume are directly proportional, which you can also remember with this equation, which is pressure, temperature, and volume. Explain changes of state in terms of kinetic particle theory, including the interpretation of heating and cooling curve. Okay, so let's do heating and cooling curve and what the kinetic particle theory is. Okay, I see kinetic particle theory here, so I'll combine them and give it together. So basically, what the kinetic particle theory states is that all matter is composed of small particles, okay, which have spaces between them and are in random motion, right? When we are looking at solids, liquids, and gases, we said solids, liquids, and gases, just don't mind the drawing. We see that these are continuously vibrating at a fixed point, these are sliding over each other, and these are randomly moving at fast speed, right? So we see that they do have what we say movement around them, so there's a random motion between them, and there's still some spaces over here, there's spaces here, and there's a lot of space here. That's why we say that in the kinetic particle theory you have spaces between the particles and they are in random motion. Then describe and explain diffusion in terms of kinetic particle theory. Now, diffusion is a pretty easy concept that you have probably learned in physics, chemistry, and biology. Basically, it's when particles move from an area of high concentration to an area of low concentration randomly. So the movement of the particles is random down the concentration gradient. What do you mean by down the concentration gradient? Imagine you have a slope like this, okay? Okay, let me draw it better. You have a slope like this, and you have a lot of particles over here, which means high concentration. As they go down the slope where there's lower concentration, this is what we call down the concentration gradient. Then we have describe and explain the rate of relative molecular mass. So molecular mass is also shown as mR in chemistry on the rate of diffusion. It's simple. The lighter gases travel faster and further because they have lighter mass, so they can go further, and heavier gases take slower and smaller distance. Now that's pretty much common sense if you get it. Then we have the cooling and heating curve, which is really important because it often comes in MCQs, and it has also come in paper 4. I'm not really sure about paper 6, but I don't think so. So we have your solid over here, you have a liquid over here, and you have your gases over here. Now this place is where the change of state happens. So over here we know that melting is what's taking place. That means that a solid, which is a reversible reaction, is turning into a liquid, and this point is called the melting point. Okay, now if that is the case, then over here what will be happening? We have a liquid to a gas, which is the process of boiling and not evaporation, because it's happening at a particular point, right? And also remember that if this line is straight, that means that the substance is pure. And how do you know if a substance is pure? Its melting and boiling point are a particular temperature, not over a range of temperature. Now the same with cooling curve. I'll have my gas on top, liquid here, and my solid here. This is my condensation point, and this is my freezing point. Okay, why? Because over here at this I have a gas changing to a liquid, and over here I have a liquid changing to a solid. Now also remember that what was I going to say? Yeah, I think that's pretty much it for this video. I think I had something in mind. Yes, the labeling. So this is basically temperature, and this denotes time, and the same over here, time and temperature. So that's all that you need to know. And please don't forget, this I remembered it. Now why is this line straight, this line straight, this line straight, and this line straight? Is because at this point energy is being given to the particles, or energy is lost from the particles. Energy is entered to the particles here, entered to the particles here to break their bonds. That's why that energy is needed to break their bond. That's why the line is straight. Over here that energy is released, which is why it's straight. And that's all for this video. Thank you for watching. Make sure to like, share, and subscribe, and I will see you in the next video, which will be chapter 2. Till then,